Okay, so I wanted to try and do something a little bit different with this one. I got the test a little bit late, and I wanted to wait until the morning time to be able to try to give a live solve to this so that it's in the legal parameter of when the test can be discussed. So I'm going to record this now a little bit early and show you what my live solve will look like for the 2023 AMC 12B. A little sleepy, but we're going to figure this out. I'm not going to be able to keep the camera on the whole time. The reason is my laptop is a 2-in-1 laptop. And when it's folded in half like that, the air cannot escape properly from the vents. And so it causes the laptop to overheat. And specifically, I'm using an external webcam, which is going to, heat up the computer even faster because it's using so much. If I change it to the onboard webcam, it looks like this. Okay, my nose, wonderful, right? Kind of terrible, actually. So we're sticking with the external mic or external webcam that I'm using, but I'm not going to be able to keep it on the whole time. I won't be able to write. The screen literally goes black. My pen won't be able to write at that time. So that's just to explain that. With no further ado, let's give this thing a go. This is unsolved before. This is first time solving it, and we will see what we can come up with. Got a stopwatch here. I'm throwing this together last minute just because I've got to get it out and get it ready to go in the morning. And I'd rather do it on screen than on the whiteboard so I can get more problems filmed faster. I am not going to explain every justification of what I'm doing. I'm going to explain some as much as I can, but some things will not be fully explained, and I hope you can piece it together. I will try to go back later and flesh out the explanations and the solution process more definitively, but I want to show kind of what it looks like under time crunch, under time pressure. I will stop myself at 75 minutes. However, obviously I'm going to be slowed down because I'm talking a little bit to you as I'm going through, and we're going to get this going. So here we go. Start the timer, switch over. I'm not going to be able to write my answers down. I'm going to circle them on screen, and I'm going to have to erase. That's the way it goes because I don't have, an input thing for the thing. So here we go. Miss Jones is pouring orange juice into 4 identical glasses for her 4 sons. She fills the first 3 glasses completely. One's out of juice when the 4th glass is only 3 1/3 full. So she's got three full glasses, 1/3 full. What fraction of a glass must Miss Jones pour? So if she has to pour and do what? All 4 glasses, same amount of juice, you're going to need to take 10/3, the total amount, and divide it by 4 so the glasses are all equal. That's going to be 5/6. Since they were full and they're now at 5/6, they have to lose 1/6. Carlos went to a sports store to buy running shoes. Running shoes were on sale with prices reduced by 20% on every pair of shoes. So if you could say 0.8x is the 20% reduction, the amount after. Carlos also knew that he had to pay a 7.5% sales tax. We're probably going to multiply that by 1.075 on the discounted price. He had $43. What is the original before discount price of the most expensive shoes he could afford to buy? I'm not going to keep the camera on the whole time, but I'll keep it on a little bit longer. Most expensive shoes that he could afford to buy. So I think this is going to be equal to 43, and I'm going to turn 0.8 into 4/5 just because I want to, and I'm going to make this 1 plus 0.075. I'm going to put the 5 into the 1 to get 0.2 and the 5 into here to get plus 0.015. That's 0.215, and I'm times 4. 4 times that is 860, or 86%, must be 0.86x equals 43. That's 86 over 100 times 100 over 86. 86 and 43 gives me a 2. 2 goes into 150 times $50. Number 3, a 3, 4, 5 right triangle is inscribed in a circle A. I'm going to clear screen. 3, 4, 5 triangle inscribed in a circle A. Okay, great. 3, 4, 5. Okay. 5, 12, 13. I'm not going to draw that one. We'll call that A, I guess. What is the ratio of the area of circle A to the area of circle B? All circles are similar. Find their radii. We will get their ratio of similarity, and we can then just square that because it's the area versus the length. That's a small notebook concept. If you had my class over the weekend, you'd be reminded of that. Now, other thing you would know would be what? That it's a right triangle, so the midpoint of the hypotenuse is the circumcenter, which means that's the circumradius, which means it's 5/2 and 13/2. Midpoint of the hypotenuse is the circumcenter. Half of the hypotenuse is the circumradius. Square to get 25/4. Square to get 1. I lost the thing. My pen button. One, hard to explain, but the pen has a button on it, and when you hit it, you lose the writing utensil. So 25/4, 169/4, 5/2 cancels 13/2. And then what am I doing? Sorry, this is the area. We're looking for what? A is the small one. A is that one to that one. So it's going to be, the 4 is going to cancel when you put it in a ratio. So 25/169D. All right, 4. Jackson's paintbrush makes a narrow strip with a width of 6.5 millimeters. Jackson has enough paint to make a strip 25 meters long. So how many square centimeters of paper could Jackson cover? I mean, I guess I'm just kind of 6.5 millimeters, and this is 25. I mean, just the product. So 25 times 6, 150, and half is 162.5. That's there, but something doesn't seem right. Millimeters to meters to centimeters. Okay, that's the game. Something's got to be weird, right? It can't just be straight up. Like, it's number 4 on an AMC 12. It's not like, it can't just be multiply. Something's got to be happening. So 6.5 millimeters is going to be converted to centimeters. 1,000 millimeters is 1 meter. There's 100 centimeters in a meter. So 10 millimeters equals 1 centimeter. So if I have 6.5 millimeters, I'll move the decimal place over and get 0.065. The 25 meters is 2,500 centimeters. Let's do scientific notation here. So we're going to go 0.065 is going to be 6 point, wait, it's 0.65. Okay, 0.65. It's you use 1/10. So 6, it's going to put it back as 65 times. I keep losing that pen button. I hate that little button. It's annoying. 65 times 10 to the negative 2 times 25 times 10 to the second. I like the cancellation. You're going to get 65 times 25. How about we do 65 times 20 plus 5? 2 times 65, 130 with a 0. 5 times 65, 325. 1625, C. Okay, I'm going to clear screen and scroll down. Number 5, you are playing a 2x1 rectangle. Playing a game, a 2x1 rectangle covers 2 adjacent squares, either horizontally or vertically, of a 3x3 grid of squares. Let's just draw the grid, get a feel for what they're talking about. So 3x3 grid of squares, but you are not told which 2 squares are covered. Your goal is to find at least one square that is covered by the rectangle. Okay, so what is this? Is a turn consists of you guessing. This is Battleship. We're playing Battleship. Okay, great. If you didn't play Battleship, it's just a board game from, I don't know, Mattel, Hasbro, something like that. Probably the same company by now. 2x1 rectangle covers 2 adjacent squares. So, okay, we got it. You're looking for the small battleship, essentially. A turn consists of you guessing a square, after which you are told whether that square is covered by the hidden rectangle. What is the minimum number of turns you need to ensure that at least one, so only one, of your guessed squares is covered by the rectangle? If you go center, is that good or bad? If you go center, you can go, where would you have to go? You wouldn't need to go here anymore, but you would have to go there. What you might, or if you went here, you'd still have to go here, because you kind of have to work about that battleship. What if we go center again, but we go here and here and here and here, we're at 5 there, but can we do better? What if we instead of targeting middle, what if we take these sides, cardinal directions? Cardinal directions, that's going to be it. You got everything's covered. All your 2x1s are covered. Cardinal directions, is it going to be 4 of those? I don't think you can do with 3. There's a 3 there, though. How could I be sure you can't get 3? Even if like this right here, it blocks 1, 2, you're actually covering 4 squares with 1 square. If I could do that on the other side, I would still need to be able to block off a battleship on the bottom row and the top row. Gonna go with 4. Clear screen. Number 6. When the roots of the polynomial are removed from the real number line, what remains is the union of 11 disjoint open intervals. On how many of these intervals is P of X positive? I am going to turn off camera now. I'm sorry, but it's starting to overheat. I can tell right now. And my AC is already turned low. So camera's going to have to go. Just follow the sound and I'll talk through it. Okay, when the roots of the polynomial P of X equal X minus 1 to the first times X minus 2 squared times X minus 3 cubed, all the way to X minus 10, got it, are removed from the real number line. So if you remove roots, like polynomial, you're removing this and this, okay? What remains is the union of 11 disjoint, so they're not going to be connected. On how many of these intervals is P of X, the Y value, positive? If you ever played this game when you solved these, like X minus 2 times X minus 3, and you had to graph that, what you would do is you would do 1, 2, and 3. And for a cubic polynomial, you'd pass through like this. And if instead you wanted like less than 0, then you would want this part here and this part here. That's what I'm going to use. So is that all it is? 1 to 10, and they're in a row? Oh, no, some of their exponents are different. So we've got exponents of 1, 2, 2. Okay, so all the exponents are 1 to 10. 1 to 10 is 10 times 11 over 2, 55. So you have 55 for your total roots, which means it is going to be odd. And odd will be ending here and ending there on the graph. Even exponents kiss off the x-axis. They'll bounce right off of it instead of pass through. It looks like odd roots have odd degree and even roots have even degree. I'm going to clear screen. If I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to pass through and put 2, 4, 6, 8, 10. We pass through at 1. We kiss off of 2. Pass through at 3. Kiss off of 4. Pass through 5. Kiss off 6. Pass through 7. Bounce off of 8. And through 9. And bounce off of 10. Okay. So we want above the x-axis. That's all that means. You've got 1, 2, 3, 4, 5, 6 intervals. The last one, it will count because you do end going to infinity, positive direction. So 6, 6, C. Next up, all right, 7. For how many integers n does the expression log of n squared? Now, observe the log rules. The 2 could come in front of this log. It cannot on this log. So minus log n squared. But we also have a log n here. What if I make this 2u minus u squared over u minus 3 square root? So I cannot cancel. I cannot split my denominator into 2. I could factor a u out of here, but I'm not going to get anything better. You just have u times 2 minus u over u minus 3. For how many integers n does this expression represent a real number where log denotes the base 10 logarithm? We just want real. We don't need an integer, just real. Basically, if it's talking about real, we want positive inside. So Okay, so what can we do here? I'm gonna have to blow my nose, unfortunately. Sorry about that. Okay, so what can we do here? Log n minus that. Okay, brain's spacing out right now. Trying to process. Okay, so 2 log n minus this. I guess if we want positive, we want a numerator positive and a denominator positive, or both negative. Okay, so when would the denominator be positive? If this was log of 1,000, log of 1,000 would mean that n was 1,000. If that was that, it would be 0. So therefore, I would need n greater than 1,000. How would that play over here? 1,000 would be log of 10 cubed squared, which is 10 to the 6, which is just 6, minus log of 1,000 would be 3 squared 9. That's going to be negative for those values. We can't go there then. We're not going to get double positive. Therefore, we're going to need double negative. I'm just going to erase some stuff here. So if we need double negative, how can that happen? Maybe if we try to reason from the u values, if I want 2u minus u squared to be less than 0, that's my numerator, and can log equals 0? The outcome of log could equal 0. A log graph goes like this. You're going to pass through at 1. The integer value, if I could make it 1, I could get 0. Should we say less than or equal to 0 then? Because that's going to make, if I made the numerator 0, it wouldn't matter what the denominator was as long as it's not 0. But we already know that when n is 1,000, it's not 0. So you're not going to get 0 in the denominator unless n is 1,000. And we're not going to use 1,000 for this. Factor out a u, 2 minus u. It's a little bit like what we just did. We want less than or equal to 0. So we say 0 and 2. And we have a what? A downward facing parabola. Wait, what? Okay, so what if we just do, let's forget it. Let's say we do simply, when does it equal 0? It equals 0 at 0 and 2. So if u could equal 0, how could I make u equals log base 10 of n? If n is 10, you're going to get 1. Wait, though. But hold on. How can u equal 0? Oh, if n is 1, because log of 1 equals 0. 10 to the 0 equals 1. Got it. Okay, so if 10 to the 0 is 1, not doing well on this problem. This is not going too comfortably right now. Brain panic. I don't know, brain freeze kind of thing going on here. So we've got, if n is 1, we say that we're going to get 0 on this term. Let's just plug 1 in and see what we get. Plug 1 in, 1 squared, log of 1 is 0. That's 0 squared. That is 0. So n equals 1 does work. I'm just having trouble with, why did my downward facing parabola, we wanted u to be greater than 2 for, because we're looking for the negative also. So if it's negative, but at 1, u is the log though. So I want my log. Okay, so since u is this log right here, u is the x value. This is my u axis, if you will. And you could think of this as a y axis. I need the u value to be greater than 2 for it to be negative. But if the u value was 0, because that's why the less than or equal, that's why that one worked when we made u equal to 0. Got it. Okay, so then now we're below the u axis here, and we've got anything greater than 2 for u. So when does log of n equal 2? 100. So log of 100 equals 2. That's correct. That would give us 0 also at that point. So you will be at 100 is okay. N equals 100. We just need N to be greater than or equal to 100. And it can't go over 1,000. So we're going from N greater than or equal to 100, less than or no, not equal to, just 1,000. So 1,000 minus 100, 900. Just to be safe, I'm going to do 999. Then I can make it less than or equal to. So now we can do B minus A plus 1. 999 minus 100, 899 plus 1, 900. 900, don't forget this one. That's little, why is that there? Okay, so that's no problem. That's probably because of the 1. That's the trap answer if you forget the 1. But the 902, is there anything we're forgetting? I'm going to clear screen for a second. If I plug in, can I plug in 0? You can't plug 0 into the argument. You can't plug it in for like it's undefined. That's the asymptote. So am I missing anything? Why is that 902 there? That's so horrible. Any other way? There's no way it could be positive. And the numerator, if it was to equal 0, what were the values? They were when u was equal to 0 or 2. And we did that one. That was when n equals 1. And that one there was specifically when n was 100. We can't be missing anything. So, in fact, we've got them all. Going with 901. Gonna clear. Gonna scroll down. Number 8. How many non-empty subsets B of 0, 1, 2, 3 to 12 have the property that the number of elements in B is equal to the least element of B? So for example, so you got a 4 and there's 4 terms. I mean, I think probably just do casework assigning the lowest element. So there's none with 0. Non-empty, empty set is this. 0 doesn't count as an empty set. It is non-empty with 0, but that's not what they're talking about. So 1, and let's go with 1. If it's 1, it's got to be 1. That's it. If it's a 2, you're going to have to choose one of these 9 numbers. There's 9, right? 0 to 12 is 13 terms, and you're leaving off 3, so definitely 9. 12 minus 3 plus, ooh, we're including, is that 12 minus 3 plus 1? Is that actually 10? 3 to 12 is 10, right? Well, it's 10. Okay, careful with that. So there's 10 of those to choose from. So we have to choose another of the 10 remaining. So you take a 2, and then you choose anything from 3 to 12, which there's 10. Okay, good. Then what? Plus, we're going to need, just keep going, right? It's just going to be, if you take 3, you now need 2 terms from the remaining. It makes me wonder if it's like hockey stick identity, if we turn it into combinations or something. What would the 10 be? It would have been 10 choose 1, right? And the 1, we could say it's 11 choose 0. We're running out of space here. Plus, I hit that button again. Of course, it changes it to a pointer on my screen is the problem. Like I want to point at something. Yeah, no, I don't. Okay, so plus, now what? Okay, so yeah, then if you reduce the pool by 1 because you're using 3, you'll now have 9 and you want to choose 2. I don't think that's hockey stick. If I changed it to 10 choose 9 or a 9, I don't see it. I feel like we're just going to have to bash the calculation. It's not Pascal's. Pascal's would have 2 of the same number in the top row, and we don't have that. We do have the marching upper term for, but the bottom number, I believe, should be staying the same for hockey stick if I remember correctly. I don't remember correctly though. I'm just going to bash it out. I don't know. 1 plus 10, and that's going to be 9 choose 2 is 9 times 8 over 2 is 36 plus 8. Is it 8 choose 3? It's got to be, right? What would the 8 choose 3 represent? Just to feel more comfortable, it would be that I chose the 4 and I have to choose 3 others from the numbers 5 to 12. 12 minus 5 is 7 plus 1, 8. It is 8 choose 3. 8 choose 3, I think it's 28 or 56. 8 times 7 times 6. The 5 factorials cancel. The 6 is 56. Okay, 56 plus 7 choose 4. 7 choose 4. You see the pattern it's developing now. You're going to have 7 and the 4 factorial will cancel. So you have 7 times 6 times 5. You'll have a 3 factorial. Remainder cancels the 6 gives 35. 35 plus. Then we got 6 choose 3. No, up 6 choose 5. 6 choose 5 is obviously 6. I always want to verify that one. What would the 6 terms be? It'd have to be from 7 to 12. So you'd have a 6 as your first term, your lowest term, and you need 5 of the remaining 6. Yes, that's correct. And that's exactly what we would have. You'd have 5 terms left. Perfect. We are aligned. I don't think you're going to get any more. Let's just, all the answers are far apart. Let's just calculate this. 36 and 56 is 80, 92, 98, 99. Grab this 10 and the 35 to get 45, 144. Nothing else is close. Even if there was one more, it would contribute minuscule. It has to be 144. I'm going to clear screen. Number 9, what is the area of the region? Okay, so now we got to think. If we, looks like, it looks a little bit like diamond graph. Diamond graph is a plus sign. If I do less than or equal to 1 for this, but there's coefficients, kind of column coefficients, if you will, of our absolute values, it would look like this, and you would be shading inside, but we don't have that. Is it just shifted or something? But I don't think I can shift unless I jump into 3 dimensions or something and say Z is the 1, or you're in the coordinate plane. You can't go 3 dimensions here. Yeah, you can't make that a Z or something. Really weird. I want to try to shift the graph, thinking of it like normal graph shifting. Like if you have circle X minus 1, squared plus Y minus 1 would make a center of 1, 1. But we don't have that situation because we have an absolute value, and it's not like any of those types of graphs. I guess we could try to define it. Define it in the quadrants. What if I target first quadrant? In first quadrant, X and Y are both positive. So I could say that this is just going to come out, but is the absolute value of X greater than or equal to 1? Because that's what's going to make this outside absolute value drop. If I did that, man. Okay, so if you're in the first quadrant, but your X is greater than or equal to 1, then you're on this side of that 1. What if I give Y the same constraint? You're on this side of the Y value of 1. You're above 1. And therefore, what that's going to allow, since you're in the first quadrant, the inner absolute value will disappear. Okay, first quadrant, inner absolute value disappears. Then if you're above 1 for Y and to the right of 1 for X, those both disappear as well. And it just becomes X minus 1 plus Y minus 1 less than or equal to 1. So you're going to have X plus Y less than or equal to 3. Move the X over. Okay, so it looks like we're in 3 now. And I guess you could try to redraw. 1, 2, 3, 1, 2, 3. You're going to be connecting from 3 to here, but you also are constrained by the 1 and the negative 1. So you're like up here, I guess. What is that? Okay, so hold on. What are we looking for? What is the area of the region? So if what's the area of that triangle? First off, is 3 times 3 over 2 is 9 over 2. And you're losing 1, so you'd be at 7 over 2. 3 point, but it's just weird feeling. I don't feel comfortable with this solve. I wonder, oh, this is taking a long time already. We're already at wow. Okay, I think I'm almost thinking about skipping right now, but what if we went back to, I just trying to think about what other approach we could use, because there's lots of different little minutia details in here. If X was between -1 and 1, but Y was, it's just a lot. I'm gonna start over. Okay, so start over. Just some clear headspace. Let's do that. Let's focus on if X, let's say that X and Y When would the outer absolute value get to come off? Let's talk about that for both of them. We'll give ourselves constraints. Instead of doing quadrants, if we say that the absolute value of x, basically absolute value of a minus b, if a is greater than or equal to b, you just take off the absolute value. So we need absolute value to x to be greater than or equal to 1. Let's talk about that at the same time that y absolute value is greater than or equal to 1. That would mean that if I'm in a space where I've got 1, I kind of cleared this whole thing off. Clear it off and zoom down maybe. Okay, good. I've got space to do that. Sorry if you can't see the screen. I got to do what I can do to make some margin space here because I can't show you paperwork if I do paperwork. Okay, so outside of 1, 1, 1, 1, you need to be greater than or equal to 1 for both. So you cannot be in this box right now. You have to be outside of it. If I do that, it will just become absolute value of x minus 1 plus absolute value of y minus 1 less than or equal to 1. That's absolute value of x plus absolute value of y less than or equal to 3. That is the diamond graph we saw in our thoughts earlier. 2 and 3, 2 and 3. But I don't know if everything in there can just be connected. What other constraints do we have? Y is more than 1. Oh, but it's not just there, actually. Yeah, no, absolute value of y is, it's absolute value of x is greater than 1. So I'm on, this side of the negative, that side of the positive. We probably should skip, but I'm stubborn right now. Okay. What if we had, I'm just going to think about something a little bit different here. What if x was between -1 and 1? Because this is kind of nagging my back thought and slowing me down. If x is between -1 and 1, then it would switch order. So x in between my kind of little tiny square right here, it would switch order to 1 minus the absolute value of x plus, and what if y, so what if we were in between like field goal posts? Now, what if they're both, okay, let's say they're both in between negative, they're inside that box. Let's do that one. 1 minus absolute value of x plus 1 minus absolute value of y. They're in the box because they're both less than 1 or greater than -1. And that means you're switching the order of the inner absolute value. And this is less than or equal to 1. Since my absolute values are now negative on the outside, I'm going to move them to the right. So I'm going to have absolute value of x plus absolute value of y greater than or equal to the 1 pulled over here. It's 1. If I was to graph equals 1, say it was equals 1, that's a diamond graph going here. However, I need to be greater than that, but within the constraints I gave myself. It's this weird thing here with the hollowed out center. Okay. So right now we've got what? An area of 2. That is there, but let's just keep going. Okay, I feel like we're getting progress though. Let's say I make the next constraint. I'm going to erase some stuff. Let's say I make the next constraint that the absolute value of x, we have the 2 already up there. Let's just put it there again. The absolute value of x is between, but the y1 is not. In other words, I'm going to be in between here, but the y value is not between -1 and 1. So I'd go like field goal posts. You are below this threshold or above the y equals 1, but your x is still between the field goal posts. So if that happened, this would still switch to 1 minus absolute value of x, but the y1 would not switch because it's greater than 1 now. The absolute value of it is greater than 1, and we do this. Now I've got 1 minus 1, that's 2. I'm going to switch the order of these so that my y is first minus the absolute value of x less than or. So this is also from the small notebook class. If it was equal to 1, then it would be the reverse diamond, kind of cut the diamond in half and go out. So we're going to have to go like this. It would look just like the inner diamond, except it's going to be like that. It's folded out essentially. But what are the other constraints here? I have to be in here. So you're getting this region, this region, this region, and this region. That's it. Okay, now if I switched it so that y was still constrained like the inner box, so we're in between here and here, and the x is not constrained, so outside of these bounds, it's going to have some symmetry. So you're going to be able to go like this. You're probably going to get one just like this and just like that. Yep. I see it coming together. We're going to have 5, 6, 7, 8 little triangles that are all 1 by 1 right triangles. So altogether, this is a whacked out graph. Altogether, you have 12 of these triangles right now, the 4 inner ones and those 8. What a fun little graph. Okay, so then what? We've got, I know we're losing so much time. This was a terrible solve. I should have skipped, but I'm so close now. I don't want to give up. Sunken cost, all that. Okay, so it's a fallacy, but I don't care. We're doing it. We got what? We've got one more thing to do. We have to do when they're both outside the constraints. And we already talked about that. That's this one. So if we're out, where's 3? This is 2 and 3. Okay, so if I connect to 3 like this, and I come down here, where's it going? Like that? Oh, it's not going to be good there. Hold on, let's get back to that. I think my scale's off a little bit. Kind of like this, and you've got this one here, and this one here, and you're going over here. Oh, is there like a... Okay. All right, so we got this one down to here. And I think, again, the scale being off affects it. All right, so we're in that constraint. We're less than or equal to that. We're in there, but what has to be true? The x has to be outside of its bounds. So x has to be out here and out here. Well, so is it all of this? No, because y also has to be above here and below here simultaneously. Where is that? If I'm below this, I'm on this side. So below this is this one. Okay, you're getting this one, and this one, and this one, and this one. 4 more. You have 16 of these triangles. If you put them together, they're squares. It's 8. It's got to be 8. Okay, I'm satisfied. We did all the conditions. I'm moving on. I'm going to clear. Brutal. Number 10, in the XY plane, a circle of radius 4 with center on the positive x-axis is tangent to the y-axis at the origin. So radius 4, if it's hitting the origin, you've got to be coming from the, let's just go here and call that 4. You're going something like this, Okay, great. The y one now is tangent to the y-axis at the origin in a circle. So a radius 10 to the is tangent to the x-axis at the origin. So 10 about up here somewhere. Something like this. That's a terrible looking circle, but I'm okay with it. Okay, so whatever, you got that going on. What happens now? What is the slope of the line passing through the 2 points? So we want this point, obviously the origin. We just need the other point. Any line through the origin and a point x, y has slope y over x. So all we need is that coordinate right there, and we get it. Because of that, I almost want to guess that we could just bull rush the problem by guessing from the answers that like this is your y value and your x value. So like 7, 2. Let's make the equations of the circles. So we've got x minus 4 squared. Your center has to be 4 to have a radius of 4, right? Yes. Okay. Plus a y squared needs to equal 16, the radius squared. The other one's going to be x squared plus y minus 10 squared equals 100 because that's the radius squared. Okay. And 10 was the center, right? Yeah, 10, because it has to have a distance of 10 to hit the origin. 7, 2. Can I plug this point in and just cheese the problem? If I plug in 7 for x, you've got 3 squared here, which is 9, plus 4 is not 16. That's not going to work. What about 3 sevenths? 3 for it's going to be 7, 3. So I'm still getting 9 here, but I'm also getting 9 here, which is not 16. That's not working either. What about the root 29s? There's 2 of them. Maybe that's it. But how is root 29 going to work? That's your run. It's your run distance. If I put it in here, there's no way this comes out to be an integer. And that one would. So I don't think any of those are going to work. This one would give you already 29 if I tried it. But again, there's no way when I plug it into that one, you're going to have luck. So that can't be it. 2, 5. So rise, run. It's probably not going to work with the cheese, is it? 5, 2 is the ordered pair. If I plug 5 in here, I get 1 plus 4, not 16. What if I made it 10, 4, same slope, right? Then this is too big. So what if I went halfway, like 3, 7.5? That's not going to give you an integer because you're not squaring an integer. There's no way a decimal squared is going to give that to you. Ugh, I didn't want to have to solve the equations. I don't think we have a choice. We probably just lost some time there. Okay, so we're going to krill all this off. Let's solve the equations. Trying to avoid pain, and unfortunately, we just wasted time. So we're going to go ahead and do this. It is what it is, but obviously, it's a system of 2 equations, 2 unknowns. Let's expand the left one in the upper left part of my screen. The top one in the upper left part of my screen, x squared minus 8x plus 16 plus y squared equals 16. The 16s cancel. Interesting. Should I solve for y squared? I don't know yet. What's the other one going to be? X squared plus, I don't want to replace x squared, I think. X squared plus y squared minus 20y plus 100 equals 100. Again, we cancel. I think I want to get rid of that one. It'd be the switch of this because you move them to the other side. 8x minus x squared. Ooh, kind of nice. The x squareds cancel. 8x minus 20y equals 0. Ooh, oh, this is the ordered pair. It is ordered pair. We don't care about the actual values. We just need y over x. The solution to this is the ordered pair where they pass. So it's going to be the y coordinate over the x coordinate. We don't even need to know what they are. 8 over 20 divided by 4, 2/5. It is 2/5. Cool. E, done. Clear. Moving on. 11. What is the maximum area of an isosceles trapezoid that has legs of length 1 and one base twice as long as the other? You know what that reminds me of? Is triangle midsegment. And it's very interesting if we went ahead and we said, okay, this is x and 2x, and we continued it above to make that triangle midsegment. Triangle midsegment has a 1:2 ratio and it's parallel to the base, just like the trapezoid. In fact, because of the 1:2 ratio, you would have a to 3a. This is exactly what came up in a problem we did the other day in my small notebook class with the 2020 exam and the orthodiagonals. We ended up getting something like this. So 1, 1, 1, 1, they're ones, right? And that's midpoints. And I'm doing that with that way. So can we use the triangle or do we have to go back to trapezoid? If you go to trapezoid, it's the average of the bases, 3x over 2 times the height. How are we going to get the height? I guess you could come down here, but you don't have angles. You could call this x over 2 and an unknown height, but you don't have equations. Okay, maximum area. Ooh, maximum area. How can you maximize the area? You would need to maximize the height, but you also don't know what your bases are. I think we have to use that triangle somehow then. Okay, so what if we went up here and I call this, we're on AMC 12. Yeah, so okay, so theta, we might do some trig then. 2, 2. If I maximize the area of the triangle because of the a to 3a ratio, you would by necessity maximize the area of the trapezoid. Maximizing A maximizes 3A. Got to be that. Got to be that. Okay, so what do we want? If we do, we get trig, so half AB sine of C. I probably want to use that. 1 and 1. Should I maximize the whole thing or just the upper? I think just the bottom, the upper one. So if I use 1 and 1, they're both A and B are 1s. I'm going to have half sine of C. And the maximum value of sine is when it's 90. Ooh, it's probably the 45, 45, 90 then, right? And if it's that, 2 and 2 for the whole thing now would be 4 over 2, which is 2. And again, that has to be broken into a 1:3 ratio. So each A is 1/2. A equals 1/2 because it's 1/4 of this. And then this is 3A, 3 over 2. I think that feels comfortable. What if I went back to just the 1 up here, though, just to be safe? I just want to kind of double check. Half times 1 times the sine of 90. Same thing. You're going to get half. and there's no way around it. This angle has to exist. We have to be able to take the sine of it. The maximum value with the sine is going to be when it's 90. There's no better outcome. Cannot get any better than that. We want to maximize. 3/2, going with it. All right, clearing screen. Next up, what for complex numbers, u equals a plus bi, v equals c plus di, and we know what that means. The binary operation. So they're throwing that word at us. We did talk about that in small notebook, but it's usually not with complex numbers. I said to try to guess that it was addition, subtraction. I don't think that matters here because they're defining it. We don't have to guess what it is. We're doing something with both of these. What do we get? We get AC, which is the product of the real components. Now be careful. This is just the product of the imaginary components, but not their eyes. So they're going to lose their eyes. Okay. I kind of get it. All right. Suppose Z is a complex number such that we're doing it with the same one. Let's define Z to be a plus bi. If I do that and I multiply, I'm going to get a squared. That's the two right here. That's the AC in the original, basically the two real components, plus b squared I. That's what that would mean, right? Right? Because you're both, if you have a plus bi, let's just look at it really quick. You're not multiplying this out. You're multiplying the a with the b with the b, and the i's do not multiply. You just attach the I at the end. We defined it that way. Okay, comfortable. The other one's going to be z squared plus 40. So I'm going to move down my screen here a little bit. A squared plus b squared I needs to equal. So now I need to square this. You don't need to go de Moivre because it's just squared. Let's just square it out. It's going to be a squared plus 2abi plus b squared I squared. That's negative b squared because I squared is a sign changer. It changes the sign. So I'm going to have equals a squared minus b squared plus 2abi. Where the b squared doesn't have an I anymore, right? Yeah, the i's gone. It became negative. The a squareds cancel. Look at that. Okay, so what do we want to do? We probably want to move the b squareds to one side. Ooh, I bet we do term matching. We're missing the 40. 40 is over here. Don't forget that. Plus 40. Because term matching, the b would have to be 0, and I don't see anything there. The only way this can match these two, basically, I'm going to rewrite what we have right now. We have b squared I, don't want to lose anything, equals negative b squared. And again, sorry for sloppy writing, but it's a pen on a screen, right? And we're working fast. So 2abi plus 40. So now what? B squared, you need, this has to cancel. The other side does not have a real component. B squared must equal 40. B must equal plus or minus 2. It doesn't matter. Complex numbers, define the binary operation. No, complex doesn't matter. It doesn't matter. A 2 root 10? 4 times, 2 root 10. What are we doing? What is the magnitude of Z? Okay, so all that is a squared plus b. We don't even want to care if it's plus or minus. We're squaring it anyway. That's 40. Now, what about the other part? What about the a? 2abi has to be the same as b squared. So 2ab must equal b squared. We know that b is not 0. We can divide by it. So 2a equals b. 2a equals b. If b is 2a and b squared equals 40, then if I plug 2a into there, I'm going to get 4a squared is 40. A squared is 10. Plug 10 in, square root of 50. So if it's square root of 50, it's 25 times 2. Square rooted 5 root 2e. Going to clear screen. Next one, 13. Rectangular box P has distinct edge lengths A, B, and C. The sum of the reminds me of Vietta's maybe. The sum of the lengths of all 12 edges. So let's call the 12 edges. You got 3 of each kind of edge, 4 of each kind of edge. Yeah, it's a box, right? Box. So 4a, I'm just going to write it 4 plus, I'm going to anticipate Vietta's possibly here. 4 times the sum of those values of that. Okay, and what is it equal to? It's equal to 13. They told us, good. The sum of all the areas of all 6 faces. Now, the areas are going to be AB. There's 2 products. You have opposite sides the same. So you're going to have an AB, a BC, and AC, you're going to double that. 2 times AB plus BC. Good. That is the area of the whole box. That's 6 total areas, which is what we want. That needs to equal 11 over 2. Furthermore, we have pairwise product of the roots in there. Pair of it, if it's a polynomial that we're doing roots of. Okay, and the volume of P, the box, that's the product of the roots. This is so clearly got to be associated with Vieta's. What is the length of the longest interior diagonal connecting 2 vertices of P? If you've ever done a rectangular box, that's A squared plus B squared plus C squared. Okay, it's the square of all the edges, and then you square root that, just as cube, same thing. So if I want that, I want to know the sum of the squares of the individuals. How are we going to get squares? That's not part of a cubic Vieta's. So instead, maybe it's not Vieta's then. Maybe I can just take something and square it. Obviously, this would be the best choice if I take A plus B plus C and I square it. This reminds me of like the binomial expansion thing we talked about in some of the classes this last few weekends. I'm going to do an A and get an A squared. I'm going to get an AB and an AC. Not only that, when B goes, it's going to give me a BA. I'm going to get 2 ABs. Obviously, you're going to get one of each of the squares, A squared plus B squared plus C squared plus 2AB plus 2BC plus 2AC. Now, what? We're basically done. What are we? No. What does this equal? This needs to equal something. A plus B plus C, it's 13 over 4. So we have 169 over 16 currently. We squared both sides, right? Yes, that's where we're at. So then we want this. And we would, if we knew it, we wouldn't be doing this work. So we're trying to find it for this. So we need to get that. Twice, it's right there, 11 over 2. 11 over 2 turned into 16, 88 over 16. So bring that over here, 169 minus 88. Add 12, add 69, 81. 81 over 16. 81, that's so beautiful. That we move that over. That's this, 81, 9, 4, done, D. Come to clear screen. Next up, 14. For how many ordered pairs of integers does the polynomial have 3 distinct integer roots? Oh, we're running out of time. How many ordered pairs AB of integers does the polynomial? Okay, so the product of the roots, we're on cubics. We are finally doing Vieta's. Okay, so I'm going to call the roots R1 times R2 times R3. It's actually the opposite of what we're seeing. Leading coefficient is 1. It's -6. I need a product of -6, and they have to be distinct. Clearly, 2, 3, and 1 with some kind of negatives involved. Are there any 6, 1, and 1? But that's not going to be distinct. We don't have that. Okay, so 2, 3, and 1. Okay, so if I want it to be a product that's -6, I'm going to have 2 choices. I can have all 3 negatives, so -2, -3, -1, and we want ordered pairs. We're going to have to check what this is, I think. So these are my 3 roots. Product is -6. What if one of them was negative and the other 2 positive? That would also work. 2, -3, 1, 2, 3, -1. If all of these work, we're here. That's the lowest one. That's kind of alarming. Look at them switching the numbers there. That's very fascinating. They don't normally do that, where they put the order different. How fun. I like it when they do. I like it when they do things like that, because it's weird and you're not anticipating it and it's not comfortable for a second. It kind of throws you off a little. Let's just verify the A and B values come out saying, what is A? A is the sum of the roots. So I'm just going to make an A and B chart over here because we have to have ordered pairs. What if there's a duplicate? That's the problem. So for the first one up there, that top row, -2, 3, and -1, the sum of the roots is -6. Don't forget that A itself would be the opposite of the sum of the roots, so it's going to be 6. -2, 3, and 1, 4 minus 2 is 2, but I want -2. It's the opposite. 3 minus 3 is 0. That's the same no matter what. 5 minus 1 is 4, but I want -4. So it's this. Okay, now, I don't care about the B value. Let's just check the A values only, and it'll probably be fine because none of them match, so you can't get duplicates with that, right? So no duplicates to worry about there. What else then? We're only at 4, though, and everything else is higher. That's alarming. That's like a trap. What else could be happening then? We said they only have to multiply to -6. The only things that make, and they're integers, So the only other thing, I can't use a half. I can't use 12 and a half or something. They have to be something but this. Oh, but we get to use negatives. That would change it. I can make that a negative. If I make that a negative, they are all unique. They are all distinct. It doesn't say positive roots. So what would this do? I'm going to put it over the side. 6, 1, negative 1. The sum of my roots is 6. But the sum is the opposite of your sum of your roots. A is the opposite. That gives us negative 6 for A. That's unique. Okay, now what if I put the negative on the 6, 1, 1? Those are duplicates. That's not going to work. If I switch it to here, it's the same thing. There's no other way to get 6, right? Because there's still a lot more higher than this. But we did dodge that. If there's nothing higher, we can't. 6, 1, 1, and 2, 3, 1. I cannot think of anything else. We've already done all the negatives. I'm going with 5. I'm going to clear. Next up, 15. Suppose that A, B, and C are positive integers such that this is true. 210 is 14 times 15 because it's 15 squared minus 15. So because of that, I would get 15A if I manipulated this plus 14B equals C. Interesting. Okay, so which of the following state of positive integers? Don't forget that. Following statements are necessarily have to be true. If the greatest common divisor of A and 14 is 1, that would mean that A does not have, not equal to, just forget what I'm not using the normal conventional, what do I mean there? A cannot have a 2 or a 7 in it. That's what it means. If it can't have a 2 or 7, or if it does not have a 2 or 7. Okay, look at this. This is 3 times 5 times A, and this is 2 times 7 times B. So if A does not have a 2 or a 7, notice what would happen. That does, this has no 2s or 7s. So if that happened, or this happened. Okay, so what if, oh, it's just so tricky. Or both. It's an or though, meaning that if just one of the 3 conditions on the left is met, it would necessarily have to follow that whatever this is saying is true. Now understand that 210 is 21 times 10, so that's 3 times 7 times 2 times 5. Of course it is. It's 14 times 15, goofball. Okay, so so then what we say, if this does not have 2s or 7s, and that does, then C is not a multiple of 2 or 7. Guaranteed. Because you can't have a multiple of 2 plus a non-multiple of 2. Same thing with 7. This is intro to number theory stuff right here. It's just basic intro to number theory. But that would be the case. So it would not have 2s. That would be true. But what if we did something where we only made this true? I mean, just glance at the answers. 1 is in 3 of them. Interesting. So it makes me wonder if 1's part of the answer because 3 of them have a 1. If that was the case, though, if 1 does work, it would probably be this and this because 2 is in 2 of those. You'd be competing. You'd only have to determine if 3 works, of course. And then there's 3 only. Let's just figure out if 1 works. It looks like it's going to give us 3 different things to consider. If we can eliminate it or get it to work, we're going to help ourselves out. So this is a valuable time spot. Greatest common divisor of A. Okay, so I think if you just made this, but we don't meet that one. If I let B be 3, this would now be a multiple of 3. It would fail. It would fail. And it only says it has an or. If it happens 1 or, 1 does not work. Those are all done. Let's clear the screen for a second. We've made a significant conclusion. What do we have? 15A plus 14B equals C. I'm going to rewrite it. 15A plus 14B equals C. Okay, so then what? We basically eliminated all of those. It does 2 work or not is all we have to know. If we switch, it looks like it's the converse, right? If we switch it, that means the C does not have a 2, 3, 5, or 7. There's no way A could have a 2 or 7. If it did, it would force the whole thing. The left side would be divisible by 2. It forces the right side to be divisible by 2. This or both. And it only has to be one of them concludes. But in fact, it would be both, which is one of the conditions. It's 2 works, got to be E. I'm going to clear it, move on. Okay, 16. In the state of Coinland, we're running out of time. Coins have values of 6, 10, and 15 cents. Suppose X is the value in cents of the most expensive item in Coinland that cannot be purchased using these coins with exact change. What is the sum of the digits of X? Okay, we have two evens and an odd. I don't know. We could just, man, there's an upper limit. It's kind of weird. Could I hit 14 cents? No, there's no way to hit 14 cents. So I'm going to put cannot get 14 cents. What about higher than that? What about, we know 15, we know 16. What about 17 cents? No way to get 17 cents. Ooh, odd numbers. I could not do it with two evens. I would have to add the odd in to do it. That could be important. 17 doesn't work. What about 19? No. 3 sixes, no. The 15 doesn't, no. 19's not there either. I'm going to put can on this side. I can do 18 with 3 sixes. I can do 16. I can obviously do 15. 20 is obviously there. Anything with 20, of course, that's obvious. 21, a 6 and a 15 will get you 21, no problem. I think we're targeting, it's probably going to be an odd number because it's more restricted. The evens are more likely to be able to come up with the 6 and the 10, and that 6 is kind of low. 22, for instance, is 12 plus 10. You can get 22. 23, can we do 23? It would have to have a 15, which means it would have to have an 8. You cannot get 23. 24, and I don't know, is it a fast way? I don't know. I'm just going to bash it. I feel like this is going to be the best way right now. 24. Of course, 24, 3, all 4 sixes, doofus. Okay, so 24. Sorry, I talk crap to myself. it helps. 25. Yeah, 25. Of course, you get 25. 26. 26. 2 10s and a 6. 26 is there. 27. Is it 23? It's no 5 though. There's no 5. It can't be 23. So 27. Can we get 27? 15 would have to go with 12, and of course it can. 2 sixes. 28. 28. 3 sixes and a 10. Of course we can. It looks like all the evens are going to be used now. What about 20? Oh, 29. Can we do 29? If I take 15 off of 29, the only way you can get an odd number is if you use the odd number. Have to use the odd. So 29 minus 15 is 14, and you can get 14. You cannot get 29. 11 is there. 30, you can, of course, get 31. The 15 and the 6 making 21, the 10, 32. All the evens are gone now because 32 just needs a 12 and a couple 10s. 33, take away 15, you need 18. You have 18. Try just odds now, probably. 35, of course, 30. Anything with 5 is going to be fine from then on out. 37, take away 15, you're at 22. And we know 22 can work, so we're already got that. 39, there's no 12. Don't have to worry about it. How about 41? No. 43 maybe. 15, 43, 28. We already got 28 on the other side. 28's over here. I'm going to go with 29. It's got to be that. I think we're going to hit everything. It's going to be 11. 11's got to be it. 2 plus 9. Going to clear screen. Okay. The 3 sides of lengths of a triangle are in an arithmetic progression with shortest side of length 6. Okay, so interior angles measure 120. One of the interior angles. So your biggest side has to go opposite the 120. And the 120, that's a nice angle. So if I call this 6 plus common difference, 6 plus 2 common differences, obviously the biggest side would have the 6 plus 2 common differences because they're shortest side, definitely shortest side, not just one of the sides, shortest side. That 120, if we try to do angle bisector theorem, I don't think that's good. We wouldn't be able to know where we're hitting the other side. It got to be law of cosines, right? Because cosines, that's it. Okay, so 36, squaring the opposite side, 36 plus 12d is 24d plus 4d squared needs to equal. We're going to square each of these sides. So 6 squared plus 36 plus 12d plus d squared. And then what? And then it's minus 2a. Your a value in the formula is 6. Your a value also 6, or b value 6 plus d. Twice the product of the two sides not squared, and then times the cosine of 120. Cos of 60 is 1/2. Cos of 120 is negative 1/2. These get eaten. They're just gone. It becomes plus. So I'm going to have plus 36 plus 6d. Okay, good. There's that. We've got some 36s to cancel. What else can we cancel? The d squareds, want to get them together. Put the d squared on this side. We're probably got a quadratic. 3d squared. 24d, those are gone. 24d, 12d, and 6d is 18d. I'm going to take the 18d out the 12d to get 6d. So plus 6D. Is it positive? Yes. The 24 is positive. Okay, then what? We got something else left over here. We got 36, 36. Anything else? Nothing else? Nothing else? 72. Subtract 72 equals 0. Divide by 3. D squared plus 2D minus 24 equals 0. 6 and 4. D plus 6. D minus 4. D plus 6. D minus 4 equals 0. D is equal to negative 6 or 4. Can it equal? It can't be negative. It's a side. 4 is the length. What do we want now? What is the area of the triangle? 4 plugged in, 6, 10, half AB sine of C, half AB, half of 60, times the sine of 120. Sine of 120 is rad 3 over 2. 60, rad 3 over 2. Yeah, rad 3 over 2. You're building towards 1 at 90. 2, 2, 15, 15 rad 3. E. Done. Going to clear screen. We got 12 minutes. Last academic year, Yolanda, this just looks big. Let's just go beyond it. We'll come back maybe. This might be good. Each of 2023 balls is randomly placed into one of 3 bins. Which of the following is, okay, so randomly into one of 3 bins, 2023. Should we do stars and bars? Can you have 0? There's no reason why it can't have 0. Which of the following is closest to the probability that each of the bins will contain, closest doesn't mean it can't be equal, but it's weird, that each of the bins will contain an odd number of balls. I mean, your total probability maybe could be considered what? The stars and bars thing, right? With zeros, you're allowed to have zeros. You're going to have all of these. All the B's is there's going to be 2023. And then you're going to have 3 bins, which is 2 dividers. So you'd have 2025 choose 2 where the D's go. And that's not a terrible, doesn't look fun, but it's not a terrible calculation, but those answers are all nice and simple. Okay. Now, how would you determine once you have that, the chance that the dividers go so that we get odd numbers on all? I almost want to just put some dots and make a simple case. Let's say I've got 5 because that's an odd number and we have an odd number. Where would the first divider have to go such that the first bin had an odd number? I'm going to call the spaces. You could have 0, 1, 2, 3, 4, 5, 6. Where could the first divider go such that the left of it would have an odd number? This is good. I'm going to put a circle for good. And then that would be bad. This would be good. That's 3 on the left and 5 on the left. Looks like there's 3 places out of 1, 2, 3, 4, 5, 6. That's a 1 in 2 chance that your first choice produces an odd. If I add 2 dots and we make 7 dots, which are the balls, 3, 4, 5, 6, 7, you're just going to gain 2 places to put a divider, and you now have 4 out of 8. It looks like the chance that your first divider is going to go to produce an odd number when you place it. You're placing these dividers somewhere in there. 1 in 2 chance. So what would happen? Let's say we'll do some contingencies. Let's say I choose this first one right here. So right now we've got this 1, and we've got how many, in my simple case, we've got 1 divider here. There's 4 more to go. Where would the other dividers have to go? Keep in mind, I could pick this spot. Because you could double up, right? And have 0 in the middle. So I'd have 1, 2, 3, 4, 5 choices. And this would be good. And this would be good. 2 out of the 5 choices. That's 1/5. That's not there. 0.2, 0.25. I'm thinking if I have 2 out of 5, 2 out of my 5 choices would give me an odd for what remains. You're going from left to right, place first divider. Is this solid reasoning or no? What is it the same for the 7? What happens on the 7? 1, 2, 3, 4, 5, 6, 7. Your first divider. Oh, but we don't even see what happens. What if you moved it? Let's go back to this case and resolve it first. 1, 2, 3, 4, 5. If you come over here and you picked that 1, What if you didn't pick that one? What if you instead picked this one for your first choice, making you chose an odd number for your left-hand bin, 3 there. Where could you place it now? 1, 2, 3, and exactly one of those would produce odd. So you'd get 1/6. 1/6 is getting smaller, not larger. 3/10 is 0.3, but you're getting, so you're doing 1/2 times 1/3 is 1/6, about 0.16. That's 0.3, 0.25, 0.5, 0.3. This is obviously repeating, I know. 0.6 repeating. You're getting smaller than you were with the 1/5, which was 0.2. You're moving away from it. This is the smallest answer. Okay, now what if we had gone, wow. I mean, if you went all the way to the end, obviously that wouldn't be good. You'd have to maybe restrict your choice so that you didn't choose the very end on your first pick. I'm going to clear screen for a second. We're running out of time. 7 minutes. 1, 2, 3, 4, 5. Blank, 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 blank. If you went here on your first choice, everything else would have 0. They would not all have an odd number, so you wouldn't actually want to choose that. So what if we chose here, 1, or here? You'd have to choose anything but the last one would give the option to split the last one. Ooh, so actually our first probability is only going to be 2 out of 5. But for such a large number, I bet even though there's 5, there's actually 6 spots. So even though there's 20, 23, there's actually an even number of spots. But we're going to lose 1. There's going to be 2,024 spots. We're going to have like 1,011 choices. We can't put it in all the places that would choose an odd. The last one is off limits, but it's really close to a half. In fact, out of 2,020, it's just barely under a half for the first one, which would further lower the probability. It's got to be E. What about the 7 case? Let's look at one more case. 3, 4, 5, 6, 7. Choose here. You still got 1, 2, 3, 4, 5, 6, 7. You could go in this spot, 1, this spot, 2, this spot, 3. 3 of your 7, which is less than a half. So 2 things less than a half. It's got to be E. Going with E. All right, clearing. Let's go back. Or forward or back. I think back. I don't want to do Cyrus the Frog. I'm tired of frogs. All right. Last academic year, Yolanda and Zelda took different courses that did not necessarily administer the same number of quizzes during each of the 2 semesters. Yolanda's average on all the quizzes she took during the first semester was 3 points higher than Zelda's average on all the quizzes she took during the first semester. Okay, so first, Yolanda equals Zelda plus 3 average. Okay, now all quizzes she took. Then what? Yolanda's average on the second semester now. Second semester, Yolanda's average on the quiz she took in the second semester was 18 points higher than her average for the first semester. That's her average, not Zelda's. The first one was Zelda's, but now Yolanda is can we call it Yolanda 1 Z1? So Yolanda 2 is equal to Yolanda 1 plus 18. She did a much better time. These average first answer was again 3 points higher. Oh, and Y2 is additionally Z2 plus 3. Sorry, Zelda. Averages in all the quizzes. Okay, which the one of the findings cannot possibly be true? Oh, shoot, 4 minutes. Yolanda's quiz average for the academic year was 22 points higher than Zelda's. Ooh, I don't even know. Let's say they took, I almost just want to plug something in and see if we can get something. If there was like 10 quizzes on both semesters, we're saying cannot happen. Could it be 22 points higher than Zelda's? Wait a minute, though, because Yolanda's average is 3 points higher here, and her average is 3 points higher here. How could it be 22 points higher than Zelda's? Is that really it on answer A? If you're only 3 points higher on the first one and 3 points higher, that doesn't even make sense. There can't be that, right? Let's look at the other ones. I don't know. Zelda's quiz average for the academic year was higher than Yolanda's. But that seems impossible too. Cannot possibly be true. Zelda's quiz average for the academic year? How could, okay, hold on. Read it again. Same number of quizzes. Yolanda's, different courses did not necessarily, that did not necessarily administer the same number of quizzes. How could there be a way they don't have to have the same number of quizzes? Interesting. Yolanda's average in the first semester was 3 points higher than Zelda's average in all the quizzes she took during the first semester. They're different courses. Yolanda's average in all the quizzes she took during the second semester was 18 points higher than her average for the first semester. And was again, what if we stacked? Okay, so wait a minute. What if Yolanda has 3 here and Zelda has 0? 1-0 for Zelda. But Yolanda took 100 tests and got 3, but she only took 1 and got a 0. 100 threes would really, that is possible. We got 1 minute left. Yolanda's quiz average is going to be 3 points higher than Zelda's. I really don't think if it could ever be 22 points higher. Because no matter what, even if Zelda has, we might have to go with this. We might have to go with A. If Zelda, terrible idea, I know, but Zelda, if she's got, let's say 70 and Yolanda has 73, a bunch of 73s is not going to increase your average over Zelda's. I'm going to stick with it. I'm going to go with A. I feel like it's going to be right. That's going to be it for the test solve here on this live solve today. I'm going to flip my tablet, my laptop back to laptop mode. I don't know if the answers are correct. I will check them. I will upload and let you know. I'm just going to upload it. We'll determine, I guess, when answers come out. So we're going to go with that. I'm going to stop here. Our time is up. Hour and 15 minutes has elapsed. I tried to give some explanations for some things. You can ask in the comments if you'd like to know some thought process that I used or what made me think of it. A lot of it is instinct. Again, an instinct developed from knowing many concepts, from solving many problems like the 120, going for law of cosines. The fact that they said there was that 1-to-2, not there, the 1-to-2 ratio in that one problem, that is textbook mid-segment theorem. Textbook mid-segment theorem, triangle mid-segment. On 13, I thought I was doing Vietta's, and it's very similar to Vietta's, and it ended up not being it. Very interesting. That isosceles trapezoid was the one with triangle mid-segment theorem. We just covered that in my small notebook class if you took it. I see a lot of things in here that were from the small notebook, including number 9. We had the diamond graph and the diamond graph. That 9 was whack. I lost a lot of time on that. It was probably a very poor choice on my part, if I'm recapping, to stay on that question so long. I did not take my own advice. I should have skipped it 3 minutes in. My brain said no. I overrode safety protocols. You get yourself in trouble when you do that. It might have cost me a couple questions in the 20s. I don't know. I'd overall, if they're right, 19, 25, what is that? 19 times 6 is going to be 114. If it's right, and then the 6 skips is going to give me 9 points. It's going to be a 123. Not the best. Many of you are so much better than me. Honestly, I'm in awe of the talent that you guys display every year. when you get those scores of 144 plus and you're out of my league. I hope you enjoyed this test solve. I wanted to try and do one finally. It's also, I wanted to solve the AMC 12 before the AMC 10 for once. Let me know what we did at the score. I don't know if these are right at the time of this filming. I'm going to stop recording. Hope you enjoyed it. I will try to film AMC 10 solves, and I will try to discuss my predictions for cutoffs. If that stands as a score, I mean, I don't know. I'd have no idea on the 12, to be honest, even though I solved it. I mean, a 100.5 is the max they've ever had for a cutoff. I think there was definitely this number 9 was really challenging. Some people might have spent more time, maybe. I don't know. I can't think right now. I'm going to stop recording so we can upload this video and go with it. Let's see, stop video. We'll stop recording. Stop recording.